When conducting the ideate stage, we used a number of tools to help us create a design that would meet the required criteria for the project. We initially conducted research on a number of different design elements of the wheel. This included using a one-piece design rather than a two or a three-piece, identifying the best method of manufacturing for the wheel, and the material to be used. We used low-level and high-level representation during the ideate stage in order to help us generate ideas to propel us forward. For our low-level representation, we used a tree diagram to help us finalize the best outcome for each area of research. Our high-level representation was in the form of an initial CAD model. This model encompassed the outer rim, the stud pattern, and a plain disc where the spoke was to go. This allowed us to check the fit of the wheel against the hub drawing we were provided, as well as conceptualize the overall size of the wheel. From these initial idea generation tools, we were able to come up with a unique preliminary design to present to our client to help identify a direction he wanted to take in respect to the aesthetics of the wheel. We each drew inspiration from designs we liked and then made versions we wanted to see on the car. This provided Paul with 4 radically different designs to look at and make a judgment on. At this stage, he identified 2 designs that he liked in particular, and we took those both to the prototype stage. Our prototyping consisted of 3 main tools: CAD modeling, FEA, and 3D printing. The purpose of the CAD modeling was to demonstrate the aesthetic features of the wheel. As it can be seen from any angle, the CAD model provides comprehensive insight into how the wheel will look when it is machined. Using a 3D model also provides another element that can be used to demonstrate the aesthetics of the wheel, but it is also extremely important for examining the fit of the wheel on the car. It makes sense to use a 3D printed version of the wheel to make sure there are no clearance issues with the hub, brakes, or body of the car before large amounts of money are invested in machining a wheel from metal. It will also be useful for making sure that the tyres are going to fit within the wheel geometry. If there are any issues, it will be much cheaper and easier to rectify a problem before the wheel is machined. Finally, we're using FEA to prototype the wheel while it is subjected to the load cases that were given by Paul. This is a cheap and relatively quick way of identifying any issues with the design. Adjustments can then be made to make sure the design will be strong enough to deal with the loads.